There we are. Okay, welcome to this talk about vSphere performance monitoring. My name is Rudi Martinsen, and I'm working as a senior cloud engineer at Intility. I primarily work with data center stuff, and I focus on infrastructure and performance monitoring, as well as automation and integration. So I have a short agenda for this talk. I must say first that this is based on a VMworld session I did in Norway earlier this year, which was 60 minutes long, and now I had to cut it in half, so I have to rush through some of the stuff. But hopefully you'll be able to follow along. If not, I'll be here afterwards, so we can go deeper. So first off, performance monitoring and why. Of course, a silly question for most of us. We all know that we are supposed to, or expected to have full control over our infrastructure at all times, and identify issues, bottlenecks, and so forth. To do that, there are lots of different solutions out there. I listed a few of them here. I guess most of you are acquainted with the performance charts in vCenter, and maybe also some of the other results. So in our environment, we used Turbonomic for a few years, partly because of the ability to do better load balancing of our environment, but also to get a more of an overview over the performance in our whole environment across multiple hosts, clusters, and vCenters. But after a while, we saw that the 10-minute interval that Turbonomic worked on was not good enough for some of the metrics. So we tried to pull some of it ourselves and got that working. So after a while, we decided to go the full length and do all of the performance monitoring ourselves. So there's, of course, also other reasons as to why you want to do something like this yourself. The customization part is kind of a big one for us. We can add or remove metrics as we see fit. We don't pull all of the metrics from vCenter, of course. We have focused it on the ones that matters for us. The granularity is also a part, as I mentioned. The retention, another one. I guess most of us have been in a situation where we are missing the real-time stats after an hour and are unable to identify the issue we had. In our solution, we can do the retention as we see fit. We can have different retention on different metrics if we want. There's also the part of complexity. Of course, there are complexity in creating and managing this yourself, but a lot of the other commercial solutions do much more than just performance monitoring and are therefore also more complex. That little part of cost is not my responsibility, so we'll skip that. We divided this project into 3 different parts. So we had first a part of pulling data from vCenter, then storing it, and then finally visualizing. And we built this as 3 completely separate components, meaning that we can develop them separately and manage them separately. So first off, pulling data. We know that vSphere has lots of APIs and SDKs. Most of them also offers performance stats. So here you can use pretty much which one you are familiar with. We are using PowerCLI in our environment quite extensively. Now I would like to do a PowerCLI demo, but I had to skip that. We'll touch upon it later. There are lots of resources available for getting started with this. This post by Luke Deakins is a few years old, but still valid, so I really encourage you to check that one out. But after pulling the data, we need somewhere to store them. And what kind of database do you use for this? We very soon saw that a traditional relational SQL database was not a fit for this data. But there are purpose-built solutions out there, namely time series databases. So I listed a few of them here. There are others as well. You could argue that things like Elasticsearch or something like that could also be used, but these are the more purpose-built ones. We decided to work with Influx in our environment. mainly because Influx is very easy to get started with. It is, as the other ones, very fast, and it stores millions of events. And just some numbers from our first run of this project. At the time, we had around 4,000 VMs and 200 hosts in that environment we managed. And we pulled approximately 12 metrics for each and every one of these objects. We pulled at 20-second intervals, and we did not delete any data for 4 months. So if you're thinking about that, we have one timestamp will generate 50,000 rows. So 1 minute of data, 151,000 rows, and after 4 months we're up to 26 billion rows. But still, with this amount, we saw very little performance hit. Everything worked normally. Of course, if you would try to pull all of those rows, then you would probably crash the server, but who does that? You're also concerned about storage when we talk about databases. We were expecting something like this, but actually we were way below 80 gigs for this data. So it's really effective on what it should be effective at. So I won't go into all of this on this slide, but there is, you need to be aware of if you're used to working with traditional relational databases, there are some different concepts in these kinds of solutions. So I want to highlight the trade-offs especially. There are limited functionality in such databases. For instance, limited joining functionality between tables or measurements, as they are called. And also things like sorting. This Influx is currently only sorts on time. So this is something to be aware of. But it makes the database very fast and efficient about what it should be serving. So rushing through, visualizing. So how do you visualize all the data you collected? Also, again, some alternatives. All great products, but we of course chose Grafana as our solution. Again, Grafana is a very easy product to use, to get started with. It's very fast. Most of the stress is actually put on the client browser, so the Grafana server itself requires very little resources. It has lots of available data sources and panels for you. Data sources being connections to the different database solutions, panels being the graphing panels you see. And there's also a great community with lots of plugins available. Okay, so over to the demo. Again, I wanted to do a live demo, but we were not allowed to bring our own computer, so I chickened out and did a video. For this, I have a small demo environment, just one host, 3 running VMs. So this Linux VM will be my server for both Influx and Grafana. So I'm logging in, and both Influx and Grafana has great documentation online with step-by-step guides into how you install and configure the product. Here I've pre-downloaded the installers, so we'll run through the installations. First off, we'll do Influx, and Influx is a really small package, only 77 megs or something, so it installs very quick, and also it starts in seconds. So next off after this thing is Grafana. Grafana is somewhat bigger, but still only 160 megs or something. But it also has some dependencies which we need to download. So after this is finished, we'll also start the Grafana server. While we wait for that, we can do a quick show of hands. Anyone familiar with Influx or Grafana? Great. So hopefully we will have this up and running very soon. We're starting the Grafana server. It takes a bit longer to start than Influx, especially the first time, because it's creating an internal database which stores some metadata things inside. but again, it should be up and running very soon. So now we're heading into the Influx shell to see what it looks like. So Influx is a schemaless database, so it's nothing here about this internal database now, but the only thing you need to pre-create before putting data in is the actual database where you're storing things. So I'm calling this performance, and I'm going in and using that. So there's also the concept of measurements, which we can relate to as tables if we're thinking relational databases. So just to show there's nothing here at start. So if we want to insert something into this database, we'll use the insert command, then specifying a name for our metric or measurement. We'll call it table if you will. We're also able to specify some tags. This is kind of, think of it as metadata about this metric or this point. So here we are giving it a server name and also a host name, for instance. And then after this, the actual value of this point. Hit enter. Now we do a new show measurements and see that we have created a table or measurement. Now we can do our favorite select star from and get the data we just inserted. So I'm just putting in a few more lines here to have something to show in Grafana, which will be the next part. First off, verifying that we have our 3 points. Now over to the Grafana in the browser. So we'll log in. First time we need to give it a new admin password. But while after that is done, we are able to add this data source, which will be the connection to the Influx database, as I mentioned earlier. So we can see that there are a lot of available data sources out of the box. We will select Influx, of course, and give it a name. Then specify the connection string to the server. It's running on the same server as the Grafana server, so we'll use localhost. Specifying which database we want to pull data from, and I'll give it a default time interval. Being that we are working with vSphere data soon, we are specifying 20 seconds. So now back to the home screen, and we can create our first dashboard. I'll select the graph panel. Now into edit mode, and I'll check out the data sources. There's our Influx data source, and now check out the measurements, and we have our demo measurement available. So there's, we'll remove the grouping, and we see we have a line all at the end there. So specifying a minor time interval, we see our 3 points available. So it's very quick to get up and running with Influx and Grafana. But of course, this was only some fake demo data. Now we want to pull things from this vSphere environment. So for that, we're using a Power CLI, and I have a script ready for that. So hopefully you'll be able to follow along. If not, we can discuss it afterwards. But first off, I'll specify, or first of all, I'll run the script and let it work while we talk. I'll specify the different metrics we want to pull, so you can recognize the CPU stuff, some memory stuff, network, and so forth. Now I'll pull all the VMs from this demo cluster, and I'll also build some variables which I'll use as these metadata tags, which I mentioned briefly. And then use the Power CLI commandlet get stat against every one of these VMs. I'll also use the real-time parameter, which specifies that we want to pull the real-time stats and then give it all those metrics. I'm also doing a translation from the vCenter metric name into my own name, and we do this because we want to be able to pull data from different data sources into the same measurements. So if you have Hyper-V or something, you could utilize the same names there. Now I'm building this the same line which you saw earlier with the measurement name, then all of those tags, and finally the value at the end there. Then using the API for Influx, the REST API, which is the preferred way of talking to the database, I'm posting all of this data. So it has run some 5 times or something, so we should have some data available to us in Grafana. We'll add a new panel, specifying the same data source as we did earlier, and check out the measurements now and see that we have all of these available to us. So we'll stick with CPU, and we see immediately that we have a graph with the average from that cluster. I'll also add an auto refresh to verify that this is actual real-time data. If we would like to see the different VMs, we can do a different grouping. Now by using these metadata tags again. So I'll select VM, and we see we have 1 line per VM here. So in Grafana you can also specify what kind of data to get to the right unit. So now it's changed to percentage data. And we can also give it a name just to understand what it is. So it's very easy to get up and running here. We'll do a quick duplicate of this graph to build out our dashboard. So again, into edit mode, selecting memory stats, and we see we have the memory stats. So in just a few moments here, we have created our first dashboard with real-time data from our vSphere environment. So to summarize, we're pulling data from vCenter with PowerCLI, putting it into an Influx database, and then visualizing it in Grafana, all within minutes. So before I finish with a last demo, I'll want to walk you through a real-world example, which we have had in our environment. Very soon after we got up and running, we saw some regular spikes in CPU ready across the whole platform, every 15 minutes, and it looked something like this. So we hadn't seen this before because, one, the performance charts in vCenter focuses on a VM or a host, and the spikes for most of the VMs were not that big. And by using Turbonomic, we are missing these spikes because of the flattening inside the 10-minute interval they are using. But we did some troubleshooting and found that a process run by System Center was the probable cause of this spike. And together with Microsoft support, we found that it did something we didn't use, so we could safely turn it off. And we saw the results immediately. So I have a link down there with more information about this from my colleague, which works with System Center. Okay, so one final slide before we do the last demo. We all know that our infrastructure is built with more than just vSphere. We have some storage and some networking. And by using the same techniques, if your components have an API, which most of today's stuff does, and hopefully you can also get a hold of the performance stats, we can build out dashboards with containing more than just the vSphere data. So that will be the next demo. So now we'll start this one. I'll open a new Grafana instance, which is actually is a demo Grafana instance we have in our environment, but it contains real production data. Not all of the environment. I think it's 200 or 300 VMs running on Docker containers also. But we have built some demo dashboards just for an overview of the clusters. And we see that we have different metrics pulled. We also see that we have the ability to filter our dashboards based on these metadata tags I'm constantly referring to be able to have more live dashboards. We can drill down into to VM hosts, again with the filtering options at the top here, with the metric specific for this host. And these are the actual VMs running on this host at the moment. So we can select a different host just to verify that the dashboard updates itself with correct data. Drilling down into a specific VM, and a VM that has some data, we see that we at the top here have some metadata, the vCenter, the cluster, and the host it's running on, and then the different metrics. So all with the same look and feel as the other dashboards. But over to adding more data sources, we'll check out a dashboard we have for storage systems. We have several 3-par arrays in our environment, which gives us performance stats through an API. So we can build dashboards like this with throughput, business, latency, caching, and so forth, in the same unified look and feel that we have with our vSphere data. Again, with the filtering made up by these metadata tags. But of course, the real strength there is when we combine the two data. And we all know that combining the data with, for instance, a VM and what storage array it's running on, that can be difficult. But through these tags, we are tagging each VM with the storage array it runs on. So we can, if we have a storage array with some issues, we can very soon see if there's one VM doing something to this array that can cause the performance issues. Or we have a graph here where we can identify if there's lots of VMs that has storage latencies on this array. And a convenient list on the right there with all the VMs running on it, where we can drill down into specific VMs if we want to. We also have vSAN in our environment, so I think I have a dashboard on that as well. Now the vSAN dashboards in the vSphere client has gotten better than the first versions, but by using the same techniques now with the vSAN management APIs, we can pull the data from vSAN as well, and building out our monitoring solution with that data as well. So all within the same dashboard. So a couple of notes on what's next for our part. We are always looking out for more data sources to pull data from, and also utilizing the data sources we already have with more metrics if needed. We're also looking into redoing some of the pulling parts. Now we have a bunch of scripts running to pull the data. Influx has a monitoring agent named Telegraph, which recently came with a vSphere plugin, which can pull all of this data for you, so you can skip that scripting part that I did earlier, which makes it even easier to get started with this kind of thing. The drawback is that you can miss out on some of these metadata tagging, which we do all of that correlation with. We're also always looking out for increasing the usage in our organizations. All our technicians have access to this data, so even though they are not vSphere administrators, they can make use of this data in their own troubleshooting. And also we have created an API on top of Influx that we can use to add this data into different other different solutions. And we are also looking into doing some analytics on it. So at the end, I have some resources. The top one is a series of posts I did about how we created this with much more detail. This one is kind of cool, where we see how VMware GSS uses Grafana internally for vSAN monitoring, based on the CEIP data we send in. And the two on the bottom here is about that Telegraph plugin. So with that, I say thank you. We probably have